So I'm going to go through backbone fast here. We're going to go through the first topology on the left. I'm going to go for a link failure there, and a topology that does not use backbone fast. And then the same link failure on the topology on the right, where backbone fast is configured. So let's start by the topology on the left. When there is a link failure and the link goes down between switch 1 and switch 3, switch 3 is going to stop receiving configuration BPDUs completely, because normally it would only receive configuration BPDUs on root or blocking / alternate ports, because the alternate ports are going to indicate a alternate path upstream to the root bridge. But in this case, switch 3 does not have the alternate port. It's actually on this segment here, it is the designated port. So therefore, it's no longer going to be receiving configuration BPDUs, and therefore elect itself as the root. It's then going to start sending its own configuration BPDUs towards switch 4. Switch 4 is going to compare the bridge ID of what he thinks is the root, which is going to be switch 1, against the bridge ID what switch 3 told him is the root, which is going to be switch 3. See, the lower bridge ID is going to be switch 1, and therefore switch 4 then knows that switch 3 is not the root, and therefore the BPDU is inferior. Therefore the port needs to age out, which is going to take a period of the max age timer to get into the listening state. In the listening state, the configuration BPDUs can then be sent downstream towards switch 3. Switch 3 can learn about the lower bridge ID of switch 1, which is the existing root, agree on that information, and then eventually it will go through the learning state and converge back into the network. And the total time there of the convergence is going to be the period of the max age timer, which is going to be the time it took for the port to age out, which is going to be 20 seconds by default, plus a period of the forward delay, which is 15 seconds, which is going to be the time it takes to go through the listening state, and then another period of the forward delay, which is going to be another 15 seconds for the time it takes to go through the learning state there. So the total convergence time for switch 3 to get back into to understand the topology again and converge back into the topology is going to be 50 seconds. Whereas on the topology on the right here, they're going to emulate the same link failure, but backbone fast is going to be configured. The difference here is that when the link failure occurs, switch 3 is going to elect itself as the root, send the inferior BPDU to switch 4, but this time, instead of waiting for the port to age out, it's going to switch 4 is instantly going to send a root link query BPDU, where in the query BPDU it contains the bridge ID of switch 4, because he was the one that sent it, and what he believes is the best bridge ID for the root at this point, which is going to be switch 1. What switch 3 is going to do when he receives that information is compare what his existing root bridge is, what he believes is the existing root bridge, which is himself, which is going to be different from what the information sent from switch 4. So switch 4 told him that switch 1 is the root bridge, but switch 3 believes himself to be the root bridge. It therefore sends that disagreement in the root link query reply message back to switch 4. Because there was a disagreement in the information sent and received, it means that the port is then going to go through the listening state, and therefore it will learn about the better route from the configuration BPDU sent downstream from switch 4 towards switch 3, and then go through the learning state and converge back into the topology. So the total time it's going to take for switch 3 to reconverge back into this network is going to be just the period of the listening and the learning state there, instead of waiting for the time of the max age. So it's just literally the time for the listening and learning state, which is going to be 30 seconds, which is equivalent of the forward delay times 2. So what happens with the rest of the root link queries here, because they are forwarded out both the root and alternate ports or blocking ports if they exist, depending on what version of spanning tree you're using. When switch 2 receives the root link query BPDU, it's going to again compare the root, what he believes is the root bridge, to the information sent from switch 4. See that they both agree on who the root bridge is, and instead of sending the root link query reply, actually sends the information upstream toward the root, which would in this case actually be the root itself. As switch 1 is the actual root, so the information that was sent is going to list himself as the root bridge. He actually sends the root link, starts sending the root link query reply downstream towards switch 4. Switch 2 is going to relay that information down to him, and ultimately switch 4 is going to see that there was an agreement in the information that was sent, which means that the port was successful in sending the root query all the way up to the existing root bridge. So therefore, there's still a valid path to the root. Therefore, the port does not transition. It just stays as the root port, which is different to what happened down here between switch 3 and switch 4. There was a disagreement on the information, which then kicked the port into the listening state. So ultimately, the difference here is the time it took to converge. On the diagram on the left, where backbone fast was not used, it took 50 seconds, and on the right, it's going to be a period of total convergence time of 30 seconds. So the reason for that is because there was no need for the max age timer. There was no need to expire the port. The routing query was sent straight out, and the disagreement on the root bridge could be quickly identified, and there saves the 20 seconds. There would save the 20 seconds for the max age timer would normally be incurred.